Morning, kids, as the case may be. Going ahead and recording early in the morning. It's now 2:38 a.m. It's going to be a lovely day. I need you all to turn in your assignment for the angles formed by secants and tangents. I placed an assessment inside the assignment folder, so you can go ahead and get a hold of that. Let me move this out of the way. Okay, so we'll go over this later. Okay, so today we're going to be talking about special segments and circles. Okay, so let's go ahead and talk about this in detail. So if two chords are intersecting inside of the circle, just like this picture right here, this is what we have right here. We have this little deal. Let me go ahead and do this. So we have piece times piece is equal to piece times piece. And basically what they're stating is this. Let me go ahead and get the highlighters. Yeah, there we go. We take this piece, which is going to correspond to this one over here. Then we're going to take this other piece, multiply it by that. So it's going to correspond to that. Then we're going to take another piece out of the circle, which is this particular segment, and times this last one. So that's basically piece times piece is equal to piece times piece. So when we're talking about this mathematically, since, whoops, I do not know why it does that. I need to teach it some manners. Anyway, we have that this unit is 12 units, and basically it says that these two are the same right here, so this is also 12 units. So we have 12, which is our first piece, times 12 is equal to 3 times x. So then we just solve for x. So as you know, we have 12 times 12. Let me go ahead and get rid of that. And then we're going to divide that by 3. So that's a total of 48. So our answer here is 48. Well, 12 times is 144. Divide both sides by 3. So 48 is equal to x. All right. Same thing right here. So we had to take this piece times this one, and then this piece times this one. So we have 6 times x minus 1 equal to 4 times x plus 3. So 6x minus 6 equal to 4x plus 12. Subtract 4x from both sides, so we end up with 2x. Then we add 6 to both sides, so we get 18. Divide both sides by 2, x is equal to 9. So 9. If that was a little bit too quick, I'll go ahead and hold that right there just for a second. Okay, I think that's long enough. You guys can pause if you need to. Alright, now we have this other case where we have secants. Remember, secants will start out, we'll go ahead and touch the circle at one point, and we'll touch at another one and go beyond the circle. We'll go through it. So basically, this is what you need to remember. Go ahead and get the highlighters again. The length of the outside of the outside length, which is just like here, is going to be multiplied by the entire length. So from here to here. So it's going to include that length on the outside. And same thing for the other part of the circle. So you can even see that right here. So just remember, the length outside times the, if you just look right here, God, that's terrible. I hate that. So the length outside times the whole length of the segment is equal to the length outside of the segment the outside part of the segment multiplied by the entire segment. That's always equal. So let's see, let's start this right here. So the length of the entire segment here is 6 plus x. And then right here, the outside is 6. So we have 6 times x plus 6 is equal to, well, the length of this entire segment is 26. So that's going to be 8, which is the outside part of the segment, times 26. Then you can do the math. So that's equal to 36, which is equal to 8 times 26. I forget what that is. So that's 8 times 26. 208. So 208. And then we subtract 36 from both sides. This is going to be a rather odd number for us. Oops. So 172, and then we're dividing that by 6, just to go ahead and do that. What is it? 36. Okay, so there's going to be 172. Whoops. Why am I doing it that way? I have no idea. Divided by 6. So you end up with x is equal to 86 divided by 3, I do believe. Yeah. So that's my x is equal to. Not going to do that one. Alright, and I know right here it says tangent squared times the outside times the whole, but just remember this part right here. Just never mind about the tangent. Just remember you're taking the length outside of the circle, which is right here. This is the length outside of the circle, times the entire length. So we're still doing that times this. So technically it is tangent squared, but just remember that it's the length outside of the circle times the entire length of the segment. So for example, we have this length right here. The length outside the circle is 12, so we have 12 times the length of the entire segment, which is also happens to be 12, which is equal to, well, let's see, our length outside of the circle is x, and the entire length is 16, so it's times 16. So this is 144 equal to 16x. Divide both sides by 16. So let's just see what that is. 144 divided by 16. 9. And that's it. That's basically it. Alright, now this is if you listen to the end of the video. Now I'm going to let you know that there's going to be a quiz, so I'm just going to go ahead and run through stuff really quick on this. So, since we have two radii right here, that means that these two angles are going to be 90 degrees. You're told that O is 140 degrees. So we're going to run this a little bit differently than we would normally. This is a quadrilateral. No, let's just work this out. Just remember, we have this arc, which is now 140 degrees, and then we have this arc. Okay? So let's see. We have 140 degrees here. We're going to take 360, subtract 140 from it. So this is going to be 220. So right here, angle X is equal to 220 minus, which is the larger arc, minus the smaller arc, which is 140, and divide that by 2. which is going to be x equal to 80, which is equal to 40. You can go ahead and pause it there if you want. That's fine. Now here we have that this we have this diagram. We're looking for x, which happens to be a radius, and all radii are equal to each other. So if this is drawn correctly, we can assume that these two segments are congruent, and we have the Pythagorean theorem. So we have 6 squared plus 8 squared is equal to x squared. That's because that's a right triangle, so that's 36 plus 64. Then this is 100. Take the square root of both sides. So 10 is equal to our x. On this diagram, we are told we have w, z, and x are. Well, these are going to be diameters, which is semicircles. We're finding the measure of arc z, w, x. Now, just remember, let me change pen color because I'm getting tired of that one right here. That this part right here is a diameter, so this part right here is 180 degrees for the arc ZW. Then we have another 50 degrees, so we have 180. We're going to add 50 to that to get the entire arc. So this is going to be 230. All right. Now this is again right here. We have 36 degrees for angle R, and that happens to be this angle, so let me go ahead and highlight that. Okay. So that's 36 degrees. So that means that this is the inscribed angle, and the arc that it intercepts, which is this angle right here, this arc, is twice that, so it's going to be 36 times 2, which is equal to 72 degrees. This is the angle they're asking for, which is equal to the arc, because that's the central angle, so it's just 72. So angle O is equal to 72 degrees. Now we're trying to find the measure of BAC, which is this angle right here. We have that the central angle is 49, so this is 49. Remember, angle BAC is equal to half of 49. So that's going to be 24.5. That's what that's equal to. Again, same thing. X is equal to 62 divided by 2. So that's going to be 31 degrees. All right, so this one's a little bit different. You have arc AEC, which is this arc all the way around here. So that's 283 degrees. You're given that this is 93 degrees right here, that's angle ACE. Now you are going to find that, so we're going to go ahead and get this arc, because it all depends on this angle. So we have 93 times 2. So that's going to be 186. So that's that our angle right there. So we're going to take 283, subtract 186, and that will give us this arc right here. Because what they're asking for is that particular angle. So let me go ahead and show you. So what they're asking for is this angle right here. So all we need to do is take that arc and divide it by 2. So let's find out what 283 minus, what is that? 186. Okay, that's 97 degrees. So this is 97 degrees right there. So we're just going to take 97 degrees and divide that by 2.